Hey guys, welcome back to the Introduction to Linear Algebra module of the Machine Learning course by Uplatz. So in the previous lecture, we have seen the basics of the linear algebra objects, correct? So we have seen what's a scalar, what's a vector, and what is a matrix, and how does a matrix looks like. Then we have seen the terms related to a matrix like order of the matrix, what is a square matrix, what is a diagonal matrix, what is a upper triangular matrix, what is a lower triangular matrix. Then we have seen scalar matrix, identity matrix, column matrix, row matrix, and what is a trace. So we will see few more things in this lecture. Okay, so we have seen what is a dot product and what is a inner product of a matrix. Okay, so we have covered these many things. So let's see today the computational rules for the matrix. Okay, so what are the computational rules? So first we will see matrix scalar operation. So when you multiply a matrix with a scalar, what happens? If you multiply, divide, subtract, or add a scalar to a matrix, you do so with every element of the matrix. Okay, and you can see the image below. The first matrix ABCD, it's a 2 by 2 matrix, and it's multiplied by a scalar value y, and you can see that the y is multiplied with every value of the matrix. Okay, so for example 4837 is the matrix and it's multiplied by 3. So 3 multiplied by 4 is 12, 3 multiplied by 8 is 24, 3 multiplied by 3 is 9, and 3 multiplied by 7 is 21. So this is the thing that happens when you multiply a matrix with scalar. Okay, so hope this is clear. Next we will see the matrix vector multiplication. So vector has only one dimension. It can be a column vector or it can be a row vector. So what happens? So multiplying a matrix by a vector can be thought of as multiplying each row of the matrix by the column of the vector. Okay, so each row of the matrix is multiplied by the column of the vector. The output will be also a vector that has the same number of rows as the matrix. So these points should be remembered, and you can solve any problem, you will get the same results. Okay, you can see that a matrix is a 3 by 2 matrix, correct? 3 rows and 2 columns, and there is a vector. Okay, then you can see each row of the matrix is multiplied by the column of the vector. So that is A multiplied by X plus B multiplied by Y. So the first row is done, then C multiplied by X, then D multiplied by Y, then E multiplied by X, and F multiplied by Y. So the example, you can see we have 1 3 4 0 2 1, which is a 3 by 2 matrix multiplied by the vector 1 5. So you can guess the output. The first value 16 we got because 1 multiplied by 1 plus 3 multiplied by 15. So that is 16. Then 4 multiplied by 1 plus 0 multiplied by 5, that is 4. Then 2 multiplied by 1 plus 1 multiplied by 5. So 2 plus 7 equals 2 plus 5 equals 7. So we got the answer is also a vector. Okay, so we got 16, 4 and 7, which has the same number of rows as the matrix, correct? So you can just see it again. So when you multiply a vector by a matrix, the each row of the matrix is multiplied by the column of the vector, and the vector will have the same number of rows as the matrix. And there is one more example here. So it's a 3 by 4 matrix, correct? So it's a 3 by 4 matrix. Each row of the matrix is multiplied by the vector. So the first operation is 1 multiplied by 1 plus 2 multiplied by 3 plus 1 multiplied by 2 plus 5 multiplied by 1. The answer is 14. Then 0 multiplied by 1 is 0. Then 3 multiplied by 3 is 9 plus 4 multiplied by 1 is 4. So 9 plus 4 is 13 we have got. Then the third row, minus 1 multiplied by 1 minus 2 multiplied by 3, 0 multiplied by 2 and 0 multiplied by 1. The answer is minus 7. So we got this output. The vector, the output is also a vector. It has 3 rows, same as the number of rows of the matrix. All right. Next, we will see matrix addition and subtraction, which is very easy and straightforward. The matrix addition and subtraction is very easy and straightforward. The requirement is that the matrices should have the same dimensions. Okay, so to add or subtract to matrix, they should be of same shape. Okay, and the result is also a matrix that has also the same dimension. That the output will also be a matrix with the same shape of the two matrices. So the first matrix is ABCD, the second matrix is EFGH. Both are 2 cross 2 matrix. So you add each the corresponding value of both matrix. It's a 1-to-1 mapping of both the matrix. So first value of the first matrix plus first value of the second matrix. Then second value of the first matrix plus second value of the second matrix. Like this, A plus E, B plus F, C plus G, then D plus H. So that is the addition, and the same applies for subtraction also. So next is matrix multiplication. So what happens in matrix multiplication? Multiplying two matrices together, it's not that hard either if you know how to multiply a matrix by a vector. Okay, so we have seen how to multiply a matrix with a vector. So that concept comes to help in this operation, the matrix multiplication. So what happens here? You can only multiply matrix together if the number of rows of the first matrix, the number of columns of the first matrix should be equal to the number of rows of the second matrix. Okay, that is a condition here for the matrix multiplication. The first condition is that the number of columns of the first matrix should be equal to the number of rows of the second matrix. So you can see in the first example, the number of columns in the first matrix is 3, and so the number of rows of the second matrix is 3, so which is compatible. So this is the first condition, and the result will be a matrix with the same number of rows of the first matrix and the same number of columns of the second matrix. Okay, so for example, if the first matrix is of the order P by Q, okay, P number of rows and Q number of columns, and the second matrix is of the order q by n. Okay, so where the q is the number of rows, which is same as the number of columns of the first matrix, and its shape is q by n. So the output, the multiplication of these two matrices, the output matrix will be of the shape p by n. Okay, so p is the number of rows of the first matrix and n is the number of columns of the second matrix. Okay, so that is the output. And one more, the easier way for multiplying the two matrices, I will tell you. You simply split the second matrix into column vectors. Okay, you can see the second matrix in the example. It's 1 3 0 1 5 2. You just split this matrix into two column vectors. The first column vector is 1 0 5. The second column vector is 3 1 2. Okay, so you split the second matrix into column vectors and multiply the first matrix separately by each of these vectors. Okay, you multiply the first matrix with the first vector, again multiply the first matrix with the second vector now. All right, so you can see that I have split the second matrix into column vectors, then I have multiplied the first matrix with the first vector, that is 1 3 2 4 0 1 multiplied by 1 0 5. The answer you can see 11 9. Similarly, the first matrix multiplied by the second vector 1 3 2 4 0 7 multiplied by, it's not 7, it's 1 I guess, so 1 3 2 4 0 1 multiplied by 3 1 2. The answer is 10 14. All right, so you can then join them. The output matrix will be 11 10 9 14. Okay, so let's see if it's correct or not. So 1 multiplied by 3 plus 3 multiplied by 0 is 0. No, 1 multiplied by 1. Okay, the matrix multiplied by the first vector. 1 multiplied by 1, then 3 multiplied by 0 is 0, then 2 multiplied by 5 is 10. So 1 plus 10 is 11, then 4 multiplied by 1 is 4, 0 multiplied by 0 is 0, then 1 multiplied by 5 is 5. So 4 plus 5, 9. So it's correct. So like that, if there is a matrix multiplication, the first condition is that the number of columns of the first matrix should be equal to the number of rows of the second matrix. Then you split the second matrix into column vectors and multiply them separately with the matrix, with the first matrix. Okay, so that's it for the matrix multiplication. Hope it is clear. Then what are the matrix multiplication properties? So let's see them one by one. The matrix multiplication has several properties that allows us to bundle a lot of computation into one matrix multiplication. So we will discuss them one by one. So the first property is not commutative. The matrix multiplication is not commutative. The scalar matrix is commutative, but matrix multiplication is not. This means when we are multiplying scalars 7 and 3, it is same as 3 multiplied by 7. But when we multiply matrix by each other, the A multiplied by B is not the same as B multiplied by A. Okay, where A and B are both matrix. So the first property is that matrix multiplication is not commutative. Then it is associative. Scalar and matrix multiplication are both associative. This means that scalar multiplication 3 multiplied by, in the bracket, 5 multiplied by 3 is same as, in the bracket, 3 multiplied by 5 multiplied by 3. So this is scalar multiplication, and the matrix multiplication also, that is A multiplied by B multiplied by C is same as A multiplied by B multiplied by C. So the first property, it's not commutative. The second property, it is associative. Third property, it is distributive. So scalar and matrix multiplication are both distributive. This means that 3 plus 3 multiplied by 5 plus 3 is same as 3 multiplied by 5 plus 3 multiplied by 3. And in case of matrix also, A multiplied by B plus C is same as A multiplied by B plus A multiplied by C. So you can just see the slide again. The first property, it is not commutative. The second property, matrix multiplication is associative. Third property, matrix multiplication is distributive. All right. So the next is the identity matrix. The identity matrix is a special kind of matrix, but first we need to define what an identity is, correct? So the number 1 is an identity because everything you multiply with 1 is equal to itself. Therefore, every matrix that is multiplied by an identity matrix is equal to itself. So for example, matrix A times 2 identity matrix is equal to A. So let's see the example. You can spot an identity matrix by the fact that it has ones along its diagonals and that every other value is a 0. It is also a square matrix, meaning that the number of rows and columns are equal. And you can see a 2 cross 2 identity matrix. The diagonal values are 1, and a 3 by 3 identity matrix. The diagonal values are 1 again, and same as 4 by 4 identity matrix. Okay, so what is an identity matrix? It's a square matrix whose diagonal values are 1 and all the other values are 0, correct? So hope it is clear. Then we see inverse and transpose. So the matrix inverse and the matrix transpose are the two special kinds of matrix properties. So let's start them one by one. So what is inverse? So first of all, a number that is multiplied by its inverse is always equal to 1. Okay. So for example, 3 multiplied by 1 by 3 is 1, correct? So a number that is multiplied by its inverse is equal to 1, and every number except 0 has an inverse. If you multiply a matrix by its inverse, the result is its identity matrix. The example you can see there, for 3, its inverse is 1 divided by 3. So 1 divided by 3 multiplied by 3 is 1, and 14 is the number, its inverse is 1 by 14. So 14 multiplied by 1 by 14 is again 1, correct? So this is the inverse. And we saw how to find the inverse for a single number, for a scalar number. Then what to do if we have a matrix? So how to find the inverse of a matrix? You can see there how to find the inverse. So for example, if 4, 7, 2, 6 is the matrix, then how to find its inverse? So we need to swap the positions of A and D. Okay, then put the negatives in front of B and C. Okay, so put the negatives in front of B and C, and then divide everything by the determinant. So the determinant is nothing but AD minus BC. So read the sentence once again. To find the inverse of a matrix, swap the positions of A and D. Okay, then put negatives in front of B and C and divide everything by the determinant. So the determinant is AD minus BC. Okay, so let's see an example. If 4, 7, 2, 6 is a matrix, then first swap the values of A and D. So you see it has become 6 and 4. Then put negatives in front of B and C. So 7 and 2 has become minus 7 and minus 2. So the matrix we have converted to 6, minus 7, minus 2 and 4. This whole divided by the determinant. The determinant is nothing but AD minus BC. So 4 multiplied by 6 minus 7 multiplied by 2. Then 4 multiplied by 6 is 24 minus 14. The answer is 1 by 10. Then this is multiplied with the matrix 6 minus 7, then minus 2 and 4. So we have got the answer as 0.6 minus 0.7, then minus 0.2 and minus and 0.4. So this is the inverse of the matrix 4, 7, 2, 6. So let's just see this once again. Next, I will tell you what's the next step. So the next thing, how do we know that the right answer? How do we know it's the inverse of that matrix? So next, what we should do, that we know that anything multiplied by inverse will be the number itself. So we have the matrix and we have its inverse. So if we multiply the matrix and its inverse, it should be equal to the identity matrix. Okay, so let's see if we get the identity matrix by multiplying the matrix and its inverse. So 4, 7, 2, 6 is the original matrix, and its inverse, what we calculated, is 0.6 and minus 0.7, then minus 0.2 and 0.4. And if we multiply them, you can see that we are doing some operations. 4 multiplied by 0.6 plus 7 multiplied by 0.2 minus 0.2. Like this, we do the calculations, and we got 2.4 minus 1.4 and minus 2.8 plus 2.8, then 1.2 minus 1.2, then minus 1.4 plus 2.4. So we have got the identity matrix, that is 1, 0, 0, 1. So it means the identity, the matrix is 1, 0, 0, 1, which means that the inverse of the matrix 4, 7, 2, 6 is the correct answer. What we got, 0.6 minus 0.7 minus 0.2 and 0.4. Okay, so this is how to find the inverse of a matrix, and it shows the matrix multiplied by its inverse, which results in a 2 by 2 identity matrix. So the inverse of 3, 4, 2, 16 is 0.4 and minus 0.1 and minus 0.05 and 0.075. So if we multiply both of them, we get identity matrix 1, 0, 0, 1. All right. Then finally, we see the transpose of a matrix. Okay. So what is a transpose? This is basically the mirror image of a matrix along a 45-degree axis, correct? It is fairly simple to get the transpose of a matrix. Its first column is the first row of the transpose, and second column is the second row of the transpose. Similarly, the third column becomes the third row of the transpose. So in simple terms, the number of columns and number of rows of the matrix becomes vice versa. Okay, the number of columns becomes the number of rows in the transpose, and number of rows becomes the number of columns in the transpose, and the column becomes the row and rows become the columns. So this is the transpose of a matrix. You can take any other examples and check the transpose. So if you have any doubts in this basics of the linear algebra, you can mail us. So we will start doing some programs using NumPy. So the NumPy package in Python has a module called linear algebra, which supports all the functions, all the operations supported by the linear algebra. Okay, so we'll start with the programs from the next class in the next lecture. All right, so if you have any doubts, you can mail us. Thank you.